So Kali Linux has around 600 pre-installed penetration testing programs, tools, including Armitage, which is a graphical cyber attack management tool, Nmap, which is a port scanner, Wireshark, a packet analyzer, Metasploit, which is a penetration testing framework, awarded as the best penetration testing software, in fact. John the Ripper, which is a password cracker. SQL Map, automatic SQL injection and database takeover tool. AirCrackNG, a software suite for penetration testing wireless LANs. Burp Suite, and OWASP Zap, web application security scanners, etc. So it was developed by Mattia Haroni and Devin Kearns of Offensive Security through the rewrite of Backtrack, the previous information security testing Linux distribution based on Knoppix. Originally, it was designed with a focus on kernel auditing, from which it got its name, Kernel Auditing Linux. Kali Linux is based on the Debian testing branch. Most packages Kali uses are imported from the Debian repositories. So the first version, 1.0.0 or Moto, this was released back in March of 2013. So with version 2019.4 in November 2019, the default user interface was switched from GNOME to XFCE, with GNOME version still available, but with version 2020.3 in August 2020, the default shell was switched from Bash to ZSH, with Bash remaining as an option. Okay, so you may know all that. So in this video, we are going to explore Kali Linux. And by the way, it's always good to refresh your memory of all the little details in case you didn't know any of that. History. Great, now you know some. But in any event, we did learn that Kali Linux user interface was switched from GNOME to XFCE. So that means that we're now going to explore the XFCE user interface. So first off, XFCE is a lightweight desktop environment for Unix-like operating systems, right? So it aims to be fast and light on system resources, while still being visually appealing and easy to use. So the XFCE desktop environment is not a single entity that provides all functionality, right? But rather it tries to adhere to the old Unix tradition of small tools that do one job and really do it well. All right, so let's go ahead and take a closer look at the Kali Linux XFCE user interface. Now, in a default session, there is a full-width panel at the top of the screen. And the top panel shows a graphical pager with a miniature view of all the workspaces. You can switch a workspace easily, a task list showing all the applications running on the current workspace, and a system tray to show status icons that are used, for example, by some media players or instant messaging applications. Over here on the top right corner, you can see the date, clock, Ethernet network, notifications, battery status. You can also lock the screen and manage your session. So over on the top left corner, you can list the applications. Here the applications are separated according to their titles, or you can list all the applications from here. It's okay too. At the bottom right corner of the application menu, though, here is where you can see the setting manager. So you manage your settings from this menu. And also up the top left corner here, you can minimize all open windows, create or open a specific folder. Open the terminal, use the command line. And with Kazam, you can record a video, or you can take a screenshot of a specific area, specific window, or full screen. And before taking a video, you can set up the speaker and microphone. Now, let me show you, if you right-click on the desktop, as you can see, you can create a launcher, URL link, folder, document. Now, if you want to open a terminal or find a folder, well, it's easy to do that too. And here's a desktop setting. You can customize your background, menu, icons. All right, so in this lecture, we're going to look at the components of Linux commands. So these are the examples of Linux commands. ls and ifconfig are command names. We're going to practice them with the next lecture, and you'll see how they work. But for now, let's examine the structure of the command components. /bin is an argument of the ls command. An argument, also called command line argument, can be defined as an input given to a command line to process that input with the help of a given command. So arguments are entered in the terminal or console after entering the command. They can be set as a path, so we could also write more than one argument together, and they will be processed in the order that they are written. Now, a parameter is an argument that provides information to either the command or one of its options. They are optional, and you're also free to use whatever parameter suits your particular needs. Single character parameters are used with a single dash. More than one parameter can be used behind a dash, so ls-al can be used instead of ls-a-l. Now, with double dash parameters, more than one character can be used, such as here, ls:\help. So in this case, a new double dash must be used for each parameter. Make sense? So as a result, the first command lists the files and directories under the /bin folder with long format by showing permissions. All right. The second command displays the detailed information about the ifconfig command. The ls command is used to list files or directories in Linux and other Unix-based operating systems. Just like you navigate in your file explorer or finder with a GUI, the ls command allows you to list all the files or directories in the current directory by default and further interact with them via the command line. -a or ~all parameters lists files or directories, including hidden files or directories. So in Linux, anything that begins with a dot, that is considered a hidden file. -l lists the contents of the directory in a table format with content permissions, size of the content in bytes, and last modified date and time of the content. -h or human readable display size information with human readable format. -s or size, where s is lowercase, lists files or directories with their sizes. -uppercase s lists files or directories and sorts by date or time in descending order, or from biggest to smallest. Finally, -t is a parameter that lists files or directories and sorts by last modified date and time in descending order, from biggest to smallest. So let's go ahead and practice. So go to Kali. Log in with the default credentials Kali and Kali. Open up the command line. Now you can change the font size from the Preferences under the File tab. Click on Change. I'm going to set size to be 14. Okay, so that's better for me. Now let's run the ls command with the help parameter and we'll be able to see some detailed information. So you can see the arguments, options, and parameters here, and you can use them when needed. They're all right here. So I'll show you some of the most common options. Now, and by the way, you can clear the screen with Control L. So let's list all the files under the /user/bin folder with -al parameter. And as you can see, we find all the files, including the hidden files, with the long listing format. And these are the permissions and last modified date of the file. So let's look at the file sizes with the human readable format. As you can see, the file sizes are more readable now. Now the next parameter is lowercase s, and it'll show you the total size and sizes of each file. And then finally, we'll use the t parameter. And it sorts the files and directories by the last modified date and time from biggest to smallest. All right, so in this lecture, we will see the pwd command. pwd stands for Print Working Directory. And as the name suggests, it prints the current directory. So let's go to Kali. Run pwd. Now, as you may remember, the tilde sign means the home directory, and you see that we are in the home directory of the Kali user. So why don't we change the directory to /user/share/nmap/scripts and list files. So now let's run the pwd command again. And as you can see, we now see the full path of the current directory. The man command. Man is the abbreviation of manual, so it gives detailed information about the named command, including name, synopsis, configuration, description, options, exit status, return value, as well as errors. Now, the manual is divided into multiple sections. So we can pass a section number as an argument to get a specific section of the manual for a given command. And this table shows the available sections. Section 1 is default. It opens the user command descriptions if no section is given. Now, if you run man password, it shows the manual of the password command. And if you specify the section number, for example, 5, it'll show the format of the file. All right, so let's go to Kali. Run man pwd to see the manual page of the pwd command. And there it opens section 1 by default. So just press Q to quit. So what if we run the man command? And of course it shows us the manual page of the man command. Say that 3 times fast. That's all right. You don't have to. Great. So obviously there's lots of detailed information about the man command, right? You can read through this at another time, but know that it's here. So this time we'll specify a section number. 1 is the default section and it shows the user command. So let's try to see section 5 of the password command. And as you can see, it shows the file formats and conversions of the password command. Now the cd command, or change directory command. This is used to change the current working directory in Linux and other Unix-like operating systems. It's one of the most basic and frequently used commands when you're working on the Linux terminal. You can specify the path of the directory. And in addition to that, you can change the directory with some special symbols. A double dot is a symbol for the upper folder. A single dot is the symbol for the current folder. So if you run cd double dot, it moves you to the previous folder. If you run cd command without any parameter, it'll give you the home folder of the current user. cd tilde user moves to the home directory of the named user. And finally, cd single dash moves to the previous position. All right, so let's go ahead and practice it. So go to Kali, change directory to /user/share/nmap/scripts. Now let's check the current folder with the pwd command. Okay. So now let's move the previous folder with a double dot. Cool, now check the current folder again. And as you can see, we have now moved to the upper folder. So let's go ahead and run the cd command without parameters and check the current folder. And you can see that we are in the home folder of the Kali user. Now if we run the cd command with dash, we'll move to the previous position. And yeah, so see how we just moved back to the Nmap folder. So let's go to the home folder again. This time use the tilde sign. Okay, great. Well, now we're back at the home folder again. The cat command is one of the most frequently used commands in Linux, Unix-like operating systems. The cat command allows us to create single or multiple files, view the contents of a file, concatenate files, as well as redirect output in terminal or files. That's where the cat command comes from, right? Concatenate. I didn't just trip over that word. Anyway, generally it's used to see the content of a text file. I'll just show you how it works, all right? So follow along. First, list files, and there are two different text files here. So let's check out the content of the my text file with the cat command. And these lines are written inside the text file. So if we want to add a new word or statement to this file, we can use a double greater than symbol. I'll just write the new line and quit with Control and C. So let's see the content of the file again. And as you can see, we added one more line to the text file. So what if we only use one greater than symbol? So let's add in a new line again, run the cat command. Single greater than symbol overwrites the entire content with the new line we just added. That's powerful stuff. So let's see the content of the my text file 2 this time. So if we run the cat command with both my text file and my text file 2, we'll see the contents of both. Now the echo command is one of the most basic, as well as frequently used commands in Linux. So it displays a line of text and the arguments passed to echo are printed to the standard output. So let's practice it. Go to Kali, run echo path, and it displays a line of text on standard output. Now, if you want to display the variables, you'll need to add a $sign to the variable. So let's run echo $path. This time it shows the path environment variable that keeps track of certain directories in Linux. So hopefully you remember cat shows the content of the file. And there is a single line in the my text file. We can also add a new line to this file with the echo command. So run echo a new line double greater than my text file. Let's see the content. And there it is. It's been added. All right, so we showed in the cat command the single greater than symbol overwrites the entire content with the new line. Just remember that. And here we have the more command. That's used to view the text files in the command prompt, displaying one screen at a time in case the file is large, for example, log files. So if you press Enter or space, it'll move to the next page. A line number specifies a line where you want to start displaying the text content. And you can press Q to quit. Let's go to Kali. All right, so we can open the syslog file because it's large enough to open with the more command. And it's under the /var/log folder. Oh, and we get permission denied. Okay, so it's an error. But as you remember, some commands, operations, or files require root privileges. And as a standard user, we won't be able to access these files, or we won't be able to perform any of these important actions. So to change the user to root, just run sudo more/var/log/syslog. Enter the password. Okay, so let's press enter or space to go to the next page. We also see how much of a percent of the file that we've already read. And press Q to exit. So let's add a line number. If we add a number with a dash, it'll display the 12 lines in a page. So let's add a number with a plus sign, and it specifies a line where you want to start displaying the text content. So it started displaying from line 123. Now, the less command is a command line utility that displays the contents of a file or command output, one page at a time. So you see how it's similar to more, but it actually has more advanced features. So you can search for a word in a file, move to a specific line, and it allows you to go both backward and forward within the line. So let's play around with that. Run sudo less/var/log/syslog. You can now press the arrow keys to go back and forward. So let's search for a database, for instance, right? /database. And yeah, there you go. It finds it easily. So now let's go to a specific line. I'll move to the 86th line, for instance. Okay, well, we cannot see the line number, but I believe that we are in the 86th line. All right, so just quit out of that. So the head command is a command line utility for outputting the first part of the files given to it via standard input. All right, so it writes the results to standard input, but by default, head returns the first 10 lines of each file that it is given. You can add a number with the -n parameter to see the first specified lines if you want. You want to see how that works? I want to show it to you. So change directory to the /user/share/nmap/scripts. List files. And as you can see, there are lots of nmap script files. So let's run one of them with the head command. And it displays 10 lines by default. So let's specify a number with the -n parameter. Okay, so this time we see the first 20 lines of this file. Here's the tail command, and it complements the head command, as you might imagine. So it'll display data from the end of the file. It'll write results to standard output. And by default, tail returns the last 10 lines of each file that it is given. It may also be used to follow a file in real time and watch as new lines are written to it. So to watch a file for changes with a tail command, just pass the -F option. This will show the last 10 lines of a file and will update when new lines are added. Hey, what about going to Kali? All right, so here we are under the /user/share/nmap/scripts folder. And let's just run any file with a tail command to see the end of the file. Okay, so if we specify the number, for example, 40, we see the last 40 lines of the file. Now let's follow a file in real time with -F parameter and see how it repeats every 2 seconds. It's very handy to watch log files that change regularly. And let's quit out of that by pressing Ctrl and C. Now grep, this is a command, well, I'll tell you that grep stands for globally search for a regular expression and then print it out. So that's why we say grep. But the grep command basically searches a file for a particular pattern of characters, and then it'll display all the lines that contain that pattern. The text search pattern is called a regular expression. So when it finds a match, it prints the line with a result. The grep command is handy when searching through very large log files, for instance. The -I parameter is used to perform case-insensitive searches. You can use regular expressions with -E parameters. -R parameters can be used to read all files under each directory recursively. And then finally, the -V parameter. We use that when we want to select non-matching lines. All right, so let's give it a shot. Let's go to Kali. Let's read the content of the /etc password file. So this is a plain text file that contains a list of the system's accounts, giving for each account some useful information like user ID, group ID, home directory, shell, and so much more. Of course, we could search for a particular pattern in this file. So let's run grep Kali /etc/passwd. And here, as you can see, it filtered the result containing Kali. So why don't we use a regular expression with the -E parameter? So Linux regular expressions are special characters which help search data and matching complex patterns. So if we add the caret symbol to the beginning of a word, it'll display the patterns that start with Kali. Now to do a case-insensitive search, we can always add the -I parameter, and we'll capitalize the first letter of Kali so that we can see the result. Now, as you can see, the result did not change. It shows the patterns that start with Kali regardless of upper or lower case. All right, so now let's perform a recursive search. So we can search for OpenVPN under the /user folder recursively. We can also see the full path of the matched pattern. Now, if you want to select non-matching mines, you can just use the -v parameter. And it shows the patterns that do not start with Kali. So the command uname displays the information about the system. -A is the option that prints out all the system information. So I'm going to give it a shot, see what it looks like. Run uname, and it displays the operating system name. Let's add the -A parameter to print all available information. And of course, respectfully, as well as respectively, the output includes the kernel name, host name, kernel release date, kernel version, machine hardware name, and operating system name. Pretty cool, huh? Puts you in the driver's seat. So redirection is a feature in Linux so that when executing a command, you can change the standard input-output devices. The standard input device, of course, is a keyboard, and the standard output device is the screen. But check this out. A single greater than symbol is used to overwrite the output file with the result set. The double greater than symbol is used to append the result set to the target file. The single less than symbol is used to add the results as an input for another command. As you may remember, we practiced output redirection while running the cat and echo commands. I wonder if you noticed. Well, let's try it here and see if you recognize it. So first run echo hello world single greater than my text file. Now look at the content of the file. We overwrite the file. So this time let's use a double greater than symbol. And this time we add a new line to the text file. So let's use input redirection. So in the previous lectures, we looked at the etc or etc/password file, and that contains a list of the system's accounts. There were some values on a line separated by a colon. Run cut-d:\f1 less than etc/password. So in the first command, we got the first values of each row with the -f1 parameter. We needed a delimiter to separate them, and we used the colon for this with the -d parameter. So we gave the etc/password file as the input to the first command by using input redirection. So, do you remember what this file looked like before? And as you can see, we extracted the first column of each line. So a pipe is a form of redirection, and it sends the output of one command to another command for further processing. So pipe is used to combine two or more commands. And in this, the output of one command acts as the input of another command. And this command's output may act as an input to the next command. It can continue, believe me. Now, pipes, it's important to note, are unidirectional, right? In other words, data flows from left to right through the pipeline. All right, so now you know all that. Let's try it out. Now in Kali, there is an important file that stores the actual password in encrypted format for the user's account, with additional properties related to the user password. The name of this file is shadow. It's under the /etc folder. So why don't we dig in and have a look at the content of this file. Oh, and of course it requires root privileges, so just add sudo to the beginning of the command. Okay, so these are the encrypted form of the user's passwords. Let's read the first 3 lines of this file with the head command. So we'll combine the 2 commands with the pipe redirection. So the output of the one command acts as an input to another command, yeah. Okay, so now change the directory to the /user/bin folder. Run ls-l pipe grep my, and the grep command takes the output of $ls-l as its input. The net effect of this command is that the output of the ls-l is displayed one screen at a time. So the pipe acts as a container which takes the output of ls-l and gives it to the grep as input. So the mkdir, the mkdir, is a command in Linux that allows users to create or make new directories. mkdir stands for make directory. So with mkdir, you can also set permissions. You can also create multiple directories or folders at once, and really so much more. You can also build a structure with multiple subdirectories using mkdir with the -p option. So why don't we just get into it and get practicing? So go to Kali. If you want to list files in a directory that doesn't exist, you're going to get this error message. So why don't we create the directory with mkdir? Change directory to the temp folder. Now, if you want to create multiple subdirectories, you can always use the -p option. And we'll check the subdirectories using the cd command. All right, no problem. They were loaded under the temp folder. The touch command is a standard program for Unix and Linux operating systems that's used to update the access and modification times of the file or files to the current time. So a file argument that does not exist is created empty. All right, so why don't we try it out? Go to Kali, list all the files that start with my, and there are 2 text files, and these are their modification times. So let's change the modification time of my text file 2. Need to create a new file with the same name as this file with the touch command. And let's check the time again. And sure enough, its modification time was updated. So now let's create a new document. And you see how an empty text file was generated under the current directory. RM. It stands for remove. So the RM command is used to remove objects such as files, directories, symbolic links, and so on and so forth from the file system of Linux. The -r parameter is used to remove directories and their contents recursively. -d parameter is used to remove empty directories. -f parameter is used to ignore non-existent files and arguments. This command normally works silently, and you should be very careful, actually, when you're running rm commands, because once you delete the files, then you are not able to recover the contents of these files and directories, all right? But with that being said, let's see how it works. So list all the files that start with temp. As you can see, I've got 2 directories. The second one, temp1, is the folder that's empty. So first I'm going to try to remove the temp folder. Now when I try to remove non-empty directories without parameters, I'll get an error. That's a good thing. So if I use -d parameter for a non-empty folder, I'll get an error again. So I need to remove this non-empty folder with the -rf parameter that forces and removes directories, like I said, recursively. So let's list directories. Okay, the temp folder is no longer available. So we'll use the -d parameter to remove an empty folder named temp1. And we'll list the directories again. What? There's no directory that starts with temp? Good job. All right. The cp command. This is going to copy files and directories or copy multiple sources to a destination directory. The -r parameters use to copy directories recursively. The mv command will move or rename files or directories, or it can move multiple sources and their files or directories to a destination directory. -f parameter is used to not prompt before overwriting. So why don't we go to Kali and you'll see what I mean. We're going to practice. We'll first list the files. So we'll copy the mytext file to the temp folder, and as you remember, dot represents a current directory. Temp folder is under the current directory, and list files in the temp folder. All right, so here it is. So now go to the temp folder. We can rename this file with the mv command. List files again. And as you can see, we changed the name of the file. So we can move this file to another folder with the mv command as well. Let's move it to the home folder of the Kali user. Run the cd command without any parameter, and that'll take us to the home folder. List the files again. Okay, so these are the copied and moved files. They were actually the same files from the very beginning. So what do we have here? Let me look for, oh, right, it's the find command. Haha. Anyway, the find command is one of the most important and certainly frequently used command line utilities in Unix-like operating systems. It's used to search and find a list of files and directories according to the conditions that you specify for files matching arguments. It has a wide range of uses. For example, you can always search by names, permissions, search depth, logical comparisons, and the list goes on. But instead of listing, let's try it out. So after typing the find command and the location that you want to search in, you need to add -iname. So this is a parameter to find files using their name and ignoring the case. So I'll search for all files that end with NSE under the root folder. Okay, so here we go. This is a great example because as you can see, I get some errors because of permissions. Now to find all files, I'll need to run this command with sudo. Okay, so now it's found all the files that end with NSE. This time I'll use a somewhat complicated command, or it's more complex anyway. Let's search some files under the root folder and use the max depth parameter. So the max depth parameter is used to specify levels of directories below the starting points. For instance, number 1 means that you're going to find a file under the root folder and 1 level down. So the command I wrote in parentheses finds folders that do not have 700 permissions. Make sense? Then finally, the remainder of the command lists these folders. Okay, enter. Of course, you need to run this command with sudo because you are searching under the root folder. And as a result of the search, this file with the permission of 600 was found under the root folder. Of course, there are many utilities available in Linux and Unix systems that allow you to process and filter text files. Cut is a command line utility that allows you to cut parts of lines from specified files or piped data and print the result to standard output. So it can be used to cut parts of a line by delimiter, byte position, and character. -F is the parameter used to select only specified fields. With the -D parameter, a delimiter is used to cut data. So, let's see how it works. Go to Kali, and the most common file to understand the usage of the cut command, I think, is /etc/password. So let's view the contents of this file again. As you can see, each data is separated by a colon. So that means that we can use the colon as a delimiter. Let's get the first fields of each line with the -F1 parameter. Okay, so this error is caused by the slash because password is a file, not a directory. So don't use the slash at the end of the file. Now let's delete it and run the command again. Okay, see how that works. We get the first fields of each row. So let's change the field numbers. You can select multiple fields just using a comma. And sure enough, we'll get the third and fourth fields of each row in the file. The first numbers are user IDs. The second numbers are the group IDs of the users. the chown command, or you may have heard chown. Either way you choose to say it, they're probably both acceptable. But anyway, the chown command changes user ownership of a file, right? Change ownership of a file, directory, or link in Linux. So every file is associated with an owning user or group. It's critical to configure file and folder permissions properly. Now, to change both the owner and the group of a file, use the chown command followed by the new owner and group separated by a colon with no intervening spaces and the target file. So let's just practice it. First, list files with the -l parameters, see the permissions. And here you can see the owner and group of the my text file are Cali. So let's change it. Run chown nobody : games my text file. Oh, right. See, this operation needs root privileges. Of course, I knew that. I'm just showing you. Yeah. Then let's run this command with sudo. List the files again. And sure enough, I set the owner as nobody and the group as games. Now, I want to talk about service and services. A service is a program that runs in the background outside the interactive control of system users as they lack an interface. So this is in order to provide even more security because some of these services are crucial for the operation of the operating system, right? All these services work on several scripts, and these scripts are stored in /etc/init.d. Okay, so this init.d is a daemon, which is the first process of the Linux system. To manage Linux services, you can use service and systemctl commands. You can learn the current status of services using the status all parameter. Service and systemctl commands are used to start, check the status of, and stop services. If the service is correctly configured, it'll start. Now, in Linux, there are several services that can be started and stopped manually in the system. Some of those services are SSH, HTTP, Tor, Apache, these kinds of things. So let's just try out what we've learned so far. And let's start the Apache service, right? So first, list all services under the /etc/init.d location. Now, these are all the services. Let's check the status of them. Run service, status all. Okay, so plus signs mean that the service is active. The minus sign means it's not active. If you do want to check the status of a specific service, for example, Apache service, use the systemctl status command. So as you can see, Apache 2 service is inactive. You can also use the service command to see the status of the service. So let's start the Apache service, run service Apache 2 start. This operation needs root privileges, so enter the password. And let's check the status again. All right, so you see it's running now. So Apache is the world's most popular cross-platform HTTP web browser to deploy and run web applications or websites. We can display the default page of the Apache server on the web browser. So just enter the IP address of the machine. And yes, this is the default page of the Apache server. It'll show us that the Apache service is running. Now, a user is an entity in a Linux operating system that can manipulate files and perform several other operations. Each user is assigned an ID that is unique for each user in the operating system. Single user, single task. Well, just as the name implies, this operating system is designed to manage the computer so that one user can effectively do one thing at a time. The Palm OS, if you remember that, for Palm handheld computers, is a great example of a modern single-user, single-task operating system. Single-user multitasking. So this is a type of operating system most people use on their desktops and laptop computers today. Microsoft Windows and Apple's Mac OS platforms are both examples of operating systems that will let a single user have several programs in operation at the same time. Kind of take that for granted these days. But I'll give you an example. It's entirely possible for a Windows user to be writing a note in a word processor while downloading a file from the internet, while printing the text of an email message. Multi-user, multitask operating systems allows many different users to take advantage of the computer's resources simultaneously. So it means that the operating system must make sure that the requirements of the various users are balanced and that each of the programs they're using has sufficient and separate resources so that a problem with one user won't affect the entire community of users. Unix, VMS, and mainframe operating systems such as MVS, these are some examples of multi-user operating systems. RTOS, RTOS, or real-time operating systems, well, these are used to control machinery, scientific instruments, as well as industrial systems. An RTOS typically has very little user interface capability and certainly no end-user utilities, since the system will be pretty much a sealed box when it's delivered for use. A very important part of an RTOS system is managing the resources of the computer so that a particular operation executes in precisely the same amount of time every time it occurs. So Wireshark is not a disaster movie set in the wide open sea. It is a free, open source, and the world's foremost network packet analyzer. And it is the de facto standard across system and network administrators. With a graphical user interface, Wireshark has the ability to listen and record traffic, as well as advanced filtering and reviewing options. So I'm going to visit a HTTP website first, then an HTTPS website. Let's go to Kali and run Wireshark. You can open a terminal screen and type Wireshark to start it. So these are the network interfaces that Wireshark is able to listen to. You can open another terminal screen and run the ifconfig command to see the network interfaces. So as you know, ifconfig stands for network interface configuration. So if we use the command without any parameter, it'll list all the interfaces available. We have ETH0 as a network interface to listen to. So now I'll turn back to Wireshark and double-click ETH0 to select it. Now Wireshark starts to listen to the Ethernet interface of Kali. And to create some traffic, I'll open a web browser and just visit an arbitrary website. And now we have enough packets to examine, so I'll click the Stop button at the upper left corner of Wireshark to stop listening to the traffic. So first, we have some DNS packets to find out the IP address of the visited site. We'll look at these kinds of packets soon, but right now let's just have a brief look. So a DNS query for the IP version 4. Another DNS query for IP version 6. Don't worry about the versions right now. We'll cover them soon, I promise. These DNS queries are transferred as UDP packets in transport layer. The destination port is 53. This is the IP packet with the source and the destination IP addresses. So we'll go through the layers one by one, and we'll see all these packets, datagrams, and frames in detail. So we'll keep going. This is the structure of the Ethernet frame. First, there are two DNS queries for www.hackeracademy.uk. One for the IPv4 address, and the other one is for the IPv6 address. And because the website is redirected to hackeracademy.uk, there are two more DNS requests for this address. Next, DNS packets are the DNS query responses. This response is type A. That means it's an answer for the IPv4 request. And here's the answer, the IP address of the website. Now, DNS response packet uses UDP at the transport layer, IP at the network layer, etc. Here we have a TCP handshake between Kali and the web server. We'll also see this in detail later on. A SYN packet, a SYN ACK as a reply, and an ACK packet to complete the handshake. This is an HTTP GET request. We learned the IP address of the website, and now the system is ready to receive the web page. HTTP protocol in application layer. Now you can see the headers and the parameters of the request. TCP protocol and transport layer, source port, destination port, flags, etc. IP protocol in network layer. Here are the source and destination addresses. And Ethernet frame in layer 2. These are the TCP packets, which will build the HTTP response. So in this example, it's the web page. In other words, the response is transferred between the web server and our system as fragmented packets in transport layer. Here's the HTTP response, 200, okay. So the web page is received. And here's the data, which is our web page. These are the response details, response type, headers, etc. Here there's additional information produced by Wireshark, which says that the HTTP response is created by reassembling 5 TCP segments or packets. So now I'd like to show you the difference between that and HTTPS traffic. So I'll go to the browser and visit an HTTPS page now. But before visiting the page, let's start Wireshark. Here's the start button. Continue without saving. Okay, now we have a clean sheet. So I'll go to the browser and hit enter. Wow, lots of packets in milliseconds. So we've got plenty of packets to investigate. Just click the stop button once again. Okay, so the DNS request and the response packets first. Here is a response with an IPv4 address. Here there's a TCP three-way handshake between Kali and port 443 of Google's web server. And now a client hello TLS packet to start the TLS handshake, again between Kali and Google's server. Now to get rid of the other traffic records, I'd like to filter the results by the IP address of the Google server. Now, while the mouse pointer is on the server IP address, right-click and go to Apply as Filter and select the Selected option. So as you can see here in the filter bar, the IP address is assigned as the destination IP address. Now, we only have to see the traffic where the destination is the Google server. But we'd like to see both the incoming and the outgoing traffic. So I'll change the DST part of the filter to ADDR and click the blue arrow to activate the new filter. Now we can see the traffic in both directions. Okay, so here we are at the Hello TLS message. Here are the details of the message. TLS uses TCP protocol in transport layer. The Google server replies a server hello message as the second step of the TLS handshake. Then comes the certificate and server key exchange, and the server hello done message is sent by the server. Kali sends the client key exchange, Google server sends the new session ticket, and the encrypted communication starts. Here is some encrypted application data, which is meaningless for others who listen to the traffic. And as you can see here, the message is encrypted at the application layer, so you can still see the source and the destination addresses, the ports, etc. This is how an IPv4 packet is seen on Wireshark. So it's a DNS query response. The fields we mentioned are seen pretty clearly. Version is 4. Header length is 5 words, which means no options field. Total length is 96 bytes. MF and DF flags are not set. And you can see the source and the destination addresses and all the rest. So have a look at what you see here. There are a lot of packets that Wireshark captures in seconds. There are some requests and responses for them, broadcasts and their replies, and etc., etc. There is an easier way to follow a stream, although this is very entertaining. The stream is a collection of packets that form a network conversation from the beginning to the end, just like your favorite story. So I'm in Kali now, and I captured the traffic just for a little bit. And while I was capturing, I visited a website to create some HTTP traffic. And here are the results: DNS packets, TCP packets, HTTP packets, etc. So I'll select an HTTP packet, and it's the GET request. Right-click, go to Follow on the submenu, and here you see the TCP stream and the HTTP stream options are both enabled. So that means we can follow either the TCP stream or the HTTP stream. So let's click HTTP stream. Now the client packets are red and the server packets are blue. The GET request by Kali, 200 OK response by OWASP, BWA. Now this is a return page in HTML format. So you can scroll down and we'll see some of the other requests and the responses and the same stream. And perhaps you're beginning to see that when you click on a link in a website or visit a website by typing its URL, there might be several consecutive requests and responses that you don't even realize. But in actuality, you don't need to know them as the end user, but we're not your typical end users now, are we? So, let's keep going. From the combo box at the left-hand side of the bottom of the stream window, you can filter the conversation from one side to another or vice versa. So at the right-hand side, right, there is another combo box where you can select the output format. Now when you close the stream window and go back to the main window of Wireshark, you can see that the stream filter is applied right here. So I'll remove the filter by clicking this cross icon. Now I see the entire captured traffic again. That is why filters exist. So in typical traffic capturing on a network interface, there are a lot of packets received from and delivered to all over the network and, wow, the internet as well. So let's see how we can take a picture of that network. Let's go to Kali and start Wireshark. You can start Wireshark from the Applications menu or open a terminal window and type Wireshark to start the app. Don't worry about the ampersand and the and of the command. Putting an ampersand at the end of a command causes the shell to run the process in the background. It's sort of multitasking. You can have many processes running, but only one in the foreground at any given point. The process in the foreground is the process that appears to have locked up the terminal. Whatever. The first message is because we are a super user on Kali. No worries. Okay. The welcome page of Wireshark asks which interface we would like to listen to first. So let's have a look at the interfaces of our system. To look at the interfaces and to remember the IP address of Kali, open a terminal and type ifconfig. There are two result sets of the ifconfig command, eth0 and lo. eth0 is the first Ethernet interface. Additional Ethernet interfaces would be named eth1, eth2, etc. Here we have only one. Now LO is the loopback interface. This is a special network interface that the system uses to communicate with itself. eth0 is the interface that we're interested in at the moment. Double-click to open the eth0 on the main page of Wireshark to start capturing the packets passing through our Ethernet interface. Now, to speed it up, let's create some network traffic. Open one of my virtual machines, OWASP BWA, and ping Kali. To stop ping command, press Ctrl-C, ifconfig, to learn the IP address of the machine. Now I go to another VM, Metasploit, and ping the last VM first. And then ping Kali. Here we have a lot of ICMP and ARP traffic at the moment. So let's generate some traffic. I open the browser in Kali and visit the website served by the OWASP BWA machine. And even more traffic. I visit nhs.uk, my favorite website. Okay, that's enough. Let's turn back to Wireshark. As you see, we have a lot of packets captured, and new packets arrive every second. ARP packets, TCP packets, TLS packets for HTTPS traffic, etc. Here we don't investigate the packets in detail. We want to learn about the systems which are interacting with us. So go to Statistics menu and select Conversations. There are 5 tabs in a conversation window by default. And we're on the IPv4 tab at the moment. Here there are IP packets grouped by address A and address B. In each line, we see how many packets sent up to now, total size of the packets in bytes, number and size of packets from A to B and from B to A, etc. There is traffic between 8.8.8.8 and my colleague. Now I know that 8.8.8.8 is the IP address of Google DNS, so I must have set the Google DNS as the DNS of my colleague. You know, I'd like to look at the network config. And yes, my DNS address is 8.8.8.8. In the Ethernet tab, we can see the MAC addresses of the systems. The addresses full of Fs mean that the packet is broadcasted. ARP requests are the examples for these kind of packets. In the TCP tab, we can see TCP packets grouped by the addresses and this time by ports as well. Because a system may have different interactions with any other system. For example, Kali may have HTTP traffic through port 80 and at the same time, it may have an SSH connection through 22 as well. Same as TCP. Packets are grouped by IPs and ports in the UDP tab. Here we have learned a lot of live systems IP addresses and MAC addresses, just listening to the traffic go through our network interface. If you'd like to investigate the traffic between the two machines, select a line, right-click. If you choose Apply as Filter from the menu, only these kinds of packets will be seen in Wireshark. I'll choose Find at this time. As you see, automatic query string is prepared. I can navigate between the packets by clicking the Find button. Go back to the conversation window. At the bottom right, there is a Conversation Types button. When you click on it, a lot of different protocols are listed. These selected 5 are the default selected protocols. You could add any protocol from the list. When you select one of them, a new tab is added to the conversation window. Hping is an excellent command line-oriented TCP/IP packet assembler analyzer. The interface is inspired by the ping 8 Unix command, but Hping isn't only able to send ICMP echo requests. It supports TCP, UDP, ICMP, and raw IP protocols, has a traceroute mode, the ability to send files between a covered channel, and many other features. So a subset of the stuff you can do using Hping: firewall testing, advanced port scanning, network testing using different protocols, TOS fragmentation, manual path MTU discovery, advanced traceroute under all the supported protocols, remote OS fingerprinting, remote uptime guessing, and don't forget TCP/IP stacks auditing. Hping can also be useful to students that are learning TCP/IP. Although it's a packet analyzer tool, it's widely used for DOS, denial of service, tests, and attacks to create IP-spoofed packets and send them to the target system. Let's see how we can use the hping command to scan the network simply. Go to Kali and open a terminal screen. Hping 3 is embedded into Kali and defined in the path, so you can use it anywhere, just typing the name of the command, hping 3. Type hping3-h or hping3-help to see the detailed usage of the hping 3 command. Let's look at a few parameters important for scanning mode. Under the mode title, we have a scan mode, and the help shows a sample usage of the mode as well. We'll use scan or 8 parameter to use Hping and scan mode. Under TCP UDP title, we have the parameters to set the flags of TCP or UDP packets. Well, you'll see the flags and meaning in this course in following lectures, so just see the Hping in action now. For example, uppercase S or SYN parameter is used to set the SYN flag of TCP or UDP packets. Let's prepare the Hping command to make a network scan. The first parameter is scan to use Hping in scan mode. Here we should say in which ports we will scan. In this example, 0 to 500 means that the ports between 0 and 500 will be scanned. You can give a port range like this with a dash between the lower bound and the upper bound. Or you can give the ports one by one, separating them by a comma. Or you can use a combination of these two. Now I want to set the SYN flag of the packet because all TCP connections start with a SYN packet. Well, again, we'll show you how a TCP handshake is made later on in the following lectures. Here comes the IP address to scan. Hit enter to start the scan. Here we have the responding ports, and the flags column says what the reply is. We sent SYN packets and get SYN ACK packets. That means ports are accessible and open to us. Now let's make another scan. This time, I'll use uppercase X to make a Christmas scan. In the scan, push, urgent, and fin flags are set in the packet, which is not seen in regular traffic. Since the packets they received are not valid packets, they've dropped them and returned no response. Although it's not the subject of our course, because it's very common usage, I'd like to show you how to perform an IP-spoofed DOS, or denial of service attack, using the Hping tool. I'm going to attack my own server. First, I'll test if I can connect to the application. So open up terminal screen and ping the application www.owaspbwa.com. Okay, I have a connection through the application. Open a browser and visit the website. Here I click a few links to show the response time of the server. Oh, okay, it's really fast. It responds as soon as I click onto links. Now let's prepare the Hping command to prepare a DOS attack. The first parameter of the command is -flood. You know what? Let's run Hping 3-help in another terminal screen to see the meanings of the parameters. Flood parameter is used to send packets as fast as possible. To make it a SYN flood attack, I set the SYN flag using -s parameter. When I send a SYN packet, since it's a legitimate TCP handshake starter, the server will try to respond to all the packets at the start of the TCP communication. So the server will be very, very busy. -v is to open verbose mode. That means we'd like to see the results of sent packets. The next parameter is rand source. This parameter will randomize the source IP addresses as if they are requested by different systems. So the attack is distributed, denial of service now. And since the IP addresses are random, the victim doesn't know about you. Give the target domain as a last parameter. Oh, by the way, the order of the parameters is not important. Hit enter to start the attack. And because we're in flood mode, no replies is shown. Let's try to click a few links to see the response time of the server while it's under attack. Click a link. It's waiting. It's obviously slowed down. Maybe our request will be timed down? So this is how a simple denial of service attack is performed. I'll stop the flood by stopping the run of the command using Ctrl-C keys. As you see, in less than a minute, we sent more than 1 million SYN packets to the victim server. No packets received because we randomized the source IP addresses of the packets. That means the responses were sent to different IP addresses. This is why we didn't receive any packets. Since I stopped sending packets, the server is now responding in good time again. Now let's repeat the attack while Wireshark is running to see what's happening under the hood. Start Wireshark. Since we're using the ETH0 interface of Kali, I'll double-click the ETH0 on the home screen to start to listen to the traffic passing through the ETH0 interface. There's still some packets on the queue because of our previous attack. I restart capturing by pressing the green button at the upper left corner of Wireshark to clean the screen before the second attack. Continue without saving. Okay, Wireshark is running and clean. We're ready to repeat the attack. You can see the number of packets at the bottom of Wireshark. As you see, we sent hundreds of thousands of packets in seconds. Nmap, Network Mapper, is a free and open source utility for network discovery and security auditing. Many systems and network administrators also find it useful for tasks such as network inventory, managing service upgrade schedules, and monitoring host or service uptime. Nmap runs on all major computer operating systems, and official binary packages are available for Linux, Windows, and Mac OS X. Nmap has been used to scan huge networks of literally hundreds of thousands of machines. Nmap is usually very good at documentation. Significant effort has been put into comprehensive and up-to-date man pages, white papers, tutorials, and even a whole book. You can visit nmap.org to find out more about Nmap. While Nmap comes with no warranty, it is well supported by a vibrant community of developers and users. It's one of the most well-known tools of the network security domain, and indeed, with a lot of facilities, it's very powerful. In addition to the classic command line Nmap executable, the Nmap suite includes an advanced GUI and results viewer, Nmap, a flexible data transfer, redirection, and debugging tool, ncat, a utility for comparing scan results, ndiff, and a packet generation and response analysis tool, Hping. Nmap uses raw IP packets in novel ways to determine what hosts are available on the network, which ports of these hosts are accessible, what services those hosts are offering, what operating systems are running, what type of packet filters, firewalls are in use, and dozens of other characteristics. Beyond all this, Nmap has its own scripting engine and allows developers to develop new modules. In the following lectures to discover the network, we'll perform the following with Nmap. First, we'll use ping scan to find out the hosts in the network. Then we'll use different types of port scan to find the open or accessible ports. We'll detect the services running on the ports and their versions. We'll try to learn the operating systems running on the systems. After that, we'll see how to use scripts with Nmap scans, and we'll learn some important scripts as well. Nmap sends some packets to discover the network. To prevent security devices from blocking our packets, here's where we're going to learn some timing tricks. Then we'll see what we can do more of to bypass security devices such as packet filters, IDS, or IPS. Here, there's an nmap command example. Let's see some basic parameters of the nmap command. Nmap is, of course, the command itself. S is to define the scan type. If you use S with uppercase T, as seen in the slide, it means you want to run a TCP scan. We'll see the important scan types in detail. If you don't use this parameter and you have the administrative privileges on the computer where you're using Nmap, SYN Scan is a default scan type. If you don't have the admin privileges on the computer, TCP Scan will run. Destination IP address is the only required parameter to run this command. It means you can run the nmap command like nmap 172.16.99.139. This is the IP address of the target machine which you want to scan. You can either give a single IP address or give an IP block or an IP range as a target, but we'll see that soon. Destination ports are the port numbers that you want to scan. If the target port numbers are not given to the command, top 1000 ports will be scanned. Be careful, I didn't say the first 1000 ports. I said the top 1000 ports. That means the most used 1000 ports will be scanned. There are different ways to enter destination ports, and we'll see them in detail. One of the very first steps in any network reconnaissance mission is to reduce a set of IP ranges into a list of active or interesting hosts. Scanning every port of every single IP address is slow and usually unnecessary. In No Port Scan option, using SN option, which was known as SP in previous releases, you tell Nmap not to do a port scan after host discovery, and only print out the available hosts that responded to the host discovery probes. This scan type is often known as a ping scan. Systems administrators often find this option valuable as well. It can easily be used to count available machines on a network or monitor server availability. This is often called a ping sweep and is more reliable than pinging the broadcast address because many hosts do not reply to broadcast queries. The default host discovery done with SN is executed by a privileged user. It sends an ICMP echo request, TCP SYN packet to port 443, TCP ACK packet to port 80, and an ICMP timestamp request by default. When executed by an unprivileged user, only SYN packets are sent using a connect call to ports 80 and 443 on the target. When a privileged user tries to scan targets on a local Ethernet network, ARP requests are used unless send IP was specified. Let's perform the first Nmap scans of the course using ping scan, also known as no port scan. Nmap is embedded in Kali and defined in the path, so you can run Nmap from anywhere just by typing Nmap in a terminal screen. When you type Nmap and hit enter, you get the help page of the Nmap. You can also look at the man page by typing man Nmap to learn more. Let's build an Nmap command to perform a ping scan. After the command itself, Nmap, I first add the parameter to define the scan type as ping scan. Note that the order of the parameters is not important in Nmap. Now, enter the only mandatory parameter, IP address. Here I enter 172.16.99.0/24. Network gurus already know what it is. Keeping it very simple, it means the IP address is between 172.16.99.0 and 172.16.99.255. That's enough. Hit enter and run the command. And the results are in. These are the hosts which are up. That means these are the systems that responded to our requests. Remember from the previous slide, our requests are ICMP echo, SYN for port 443, ACK for port 80, and ICMP timestamp requests, if the user is privileged. The IP addresses or the domain names of the systems are spread across a line. In most cases, we want to see the IP addresses of the hosts as a list to use in further scans. So what can we do to see only the IP addresses of the live systems? Well, we're going to use the power of the Linux command shell. First, let's clear some lines of the result which do not contain IP addresses. So I'll only have the lines of IP addresses. To be able to do this, I'll use grep command with pipe. Copy a static part of the IP lines, for example, Nmap Scan, and give it as the parameter of grep command. Let me give you a little tip here. If you're using a mouse, select a string in the terminal screen and press the middle button of the mouse to copy and paste the selected part. Now we only have the lines which contain the IP addresses. But wait a second, we have a domain name of a host. Let's get rid of the domain name and see only the IP address of it. In nmap command, add -n parameter to avoid the name resolution, so nmap will display only the IP address. Now we have the lines with IP addresses. Now the second step is to clear the words in the lines to have only the IP addresses. To do this, we'll use the cut command of the Linux shell. Type cut. The delimiter here is the space character. Give it with the D parameter. IP is the fifth field of the line. Give it with F parameter. Now we have the IP list of the live hosts. SYN Scan is the default and the most popular scan option for good reasons. It can be performed quickly, scanning thousands of ports per second on a fast network, not blocked by restrictive firewalls. It's also relatively stealthy, since it never completes TCP connections. It also allows clear, reliable differentiation between open, closed, and filtered states. This technique is often referred to as half-open scanning, because you don't open a full TCP connection. You send a SYN packet, as if you're going to open a real connection and then wait for a response. A SYN-ACK indicates the port is listening or open, while a RIST, reset, is indicative of a non-listener. If no response is received after several retransmissions, or an ICMP unreachable error is received, the port is marked as filtered. If you receive a SYN-ACK from the target system, you send RIST instead of the ACK packet, and you do not complete the three-way handshake. Okay, so let's perform an Nmap SYN Scan in our virtual network. Go to Kali and open the terminal screen. First, let's look at the IP address of Kali to understand the IP block. Here, my IP block is 172.16.99. This is because the net mask is 255.255.255.0. Let's create the SYN Scan command. Nmap is the command itself. S is to SYN Scan. Since it's the default scan type for privileged users and I'm already a privileged user in Kali, this parameter is not necessary for a SYN Scan. Now, here is the target IP block, 172.16.99.024. This is the IP address block from 172.16.99.0 right the way through 172.16.99.255. And let's keep it a fast scan for just the top 50 ports. I use top ports parameter for this purpose and hit enter. Now let's look at the scan results. Here we have the computers who have the IP addresses 172.16.99.1 and 2. These are the gateway and the DNS server for my virtual network, VMnet. Ignore them for now. In fact, one is my host machine at the same time. Here there is a system, and the open ports are in the top 50. But look, there's another machine, and of course, it's open ports. The machine with IP254 is the DHCP server, my VMnet, so ignore that as well. And the last machine found is the Kali itself. Okay, let's open Wireshark and see what's happening when a SYN scan is performed. Run Wireshark first. Double-click ETH0 to start to listen to that interface. Now to skip the packets, which we are not interested in, I add a filter. I only want to see the traffic from my destination computer, 172.16.99.139. And I want to see the TCP traffic only. Click the blue arrow next to the filter bar to activate the filter. Okay, now go to the terminal screen. I'd like to analyze the SYN scan packets for an open port first. 172.16.99.139 is my destination system, and I know that port 80 of that system is open. Hit enter and run the Nmap query. Yep, the port is open just as I remember. So now go back to Wireshark. I want to stop Wireshark by clicking the red square at the upper left corner to avoid unwanted packets. So here we have 3 packets. The first packet is from an arbitrary port of Kali to the 80th port of the system 139, the destination system. It is a SYN packet to start the 3-way handshake. The second packet is a SYN ACK sent by the destination system. The third packet is a RIST sent by Kali. Because it's a SYN scan, the 3-way handshake is not completed and corrupted by a RIST packet. Now I restart the Wireshark packet capturing to clean its screen by clicking the upper left blue button. Okay, so this time I scan a closed port, for example, port 81. Now the first packet is a SYN scan packet to start the 3-way handshake again. The source system is Kali, and the destination system is again 139. The second packet is, for the scan, a RIST packet. Because port 81 is closed, the destination system sent us a RIST packet. Let's see how Nmap interprets the results of SYN scan. When we send a SYN packet, the destination system replies a SYN ACK packet to show that it's ready for a connection. And we send RIST to corrupt the handshake. Nmap interprets this result as the port is open. If the destination system replies a RIST packet for our SYN packet, that means the port is accessible, but it's closed. If the destination system doesn't respond to our SYN packet, Nmap thinks that the packet is dropped or filtered. It's a common behavior of the firewalls. If the destination system replies an ICMP unreachable packet for our SYN packet, again, it's interpreted as filtered. This is another type of firewall behavior. Well, what do open, closed, or filtered actually mean? Let's take a closer look at the results of Nmap. When Nmap sends packets to a port and receives a positive response, the port is assigned the state of open. For example, SYN scan receives a SYN ACK from the destination system if the port is open. If Nmap determines that a port is not available, it assigns it the closed state. This signifies that Nmap has received a result that clearly shows that the port is closed. A SYN scan receiving a RIST in response to a port query is an example of a closed port. Filtered ports are the result of a packet filter or firewall when no response at all is received from the remote device. The port is considered to be filtered. Since a response isn't received from the port, Nmap often retries communication to the port to ensure that the packet wasn't simply dropped due to error or congestion. Please note that this type of response is categorized differently if this is a different scan type, such as a UDP scan or a SYN scan. The next result, open filtered, is coming in a minute. On the other hand, if the destination systems return an unexpected response, again the port is considered to be filtered. If we get an ICMP unreachable response in a SYN scan, the port is flagged as filtered. Now, in some cases, the lack of a response may not necessarily mean that a port is filtered. Lack of a response might mean that the port might also be open. Now, in these situations, Nmap signifies that the port is either filtered or open. For example, in a UDP connection, in most cases, the destination system does not send a response when it receives a UDP packet. So if the destination system does not respond, Nmap categorizes it as open filtered. Make sense? In this slide, you see some of the most known default ports. So here's a question. If the port 22 is open, is the service running there absolutely in SSH? Could there be another service? Well, these are the default port numbers of the services. You can run any service in any port. You can run HTTP on port 22, for example. But for the ease of use, the default ports are used in general. So if you're performing a pen test, you should probably look at the well-known ports first, but you should never just scan the default ports. There are different ways to scan ports with Nmap. Let's see how we can scan ports. Let's prepare a SYN scan for a Metasploitable device. The IP address of my Metasploitable is 172.16.99.206. If you do not use any one of the port scanning parameters, top 1,000 ports are scanned. Top ports are the most used ports in general. The first way of choosing the ports to scan is using P parameter. After entering the scan type and target IP, enter the port numbers with P parameter. You can enter ports one by one, separated by a comma, or you can give a range of ports by putting a dash between the port numbers. In this example, the ports 22, 80, and the ports between 100 and 200 are scanned. If you perform both TCP scan and UDP scan in a single Nmap query, you can choose both the UDP ports and the TCP ports using P parameter. For this Nmap scan, we'll use both SYN scan and UDP scan at the same time. We haven't seen it yet, but the UDP scan is performed using U parameter. And as you know, the SYN scan is a type of TCP scan. After entering the target IP, put -P. To enter TCP ports, put uppercase T with a colon just after the parameter P and the TCP ports to scan. Same as giving port numbers directly with P parameter. You can enter ports one by one, separated by a comma, or you can give a range of ports by putting a dash between the port numbers. To specify the UDP ports, put U as an uppercase U with a colon and the ports with the same format. For this example, let's scan the TCP ports 22 and 80 and the UDP ports 53 and the ports between 139 and 150. So here are the results, TCP ports first and then UDP ports. Now the way to specify the ports is using top ports parameter. Using this with the number of ports that will be scanned, you can scan the top ports within this parameter So let's scan top 20 ports for this example. So here are the top results of the most used 20 ports. If you use uppercase F, which means fast scan, top 100 ports are scanned. So let's perform an Nmap SYN Scan with F parameter here. And open another terminal screen and perform another Nmap scan using top ports 100 parameter. As you see, we get the same results because these are the same queries. If you'd like to scan all the ports of the system, well, you should scan all the ports of the systems in a pen test. You have to use the P parameter with the interval from 1 to 65,535. This is the range of possible port numbers. Prepare the Nmap SYN Scan query with the destination IP address. Now put P1-65535 and hit enter. Here are all the open ports of Metasploitable. By default, Nmap does host discovery and then performs a port scan against each host it determines is online. If you use pn in the Nmap query, you skip host discovery and port scan all target hosts. Disabling host discovery with pn causes Nmap to attempt the requested scanning functions against every target IP address specified. So if a class C target address space, that means 24 is specified on the command line, all 255 IP addresses are scanned. Why would we want to do this? As you know, if you're a privileged user, Nmap sends 4 types of packets to discover hosts: ICMP echo request, SYN packet to TCP 443 port, ACK packet to TCP 80 port, and ICMP timestamp request. If a system is configured not to answer to ICMP requests, and if the ports 80 and 443 are filtered, then Nmap thinks that the host is down even if it's up. If you find a system which is not found by ping scan, always use pn for further port scans. Otherwise, Nmap doesn't perform the port scan because it assumes that the host is not up. So if your network is not big, or if you don't have enough time to scan, you should skip the ping scan and run the port scans for every possible IP address. Use a port scan instead of ping scan if you were scanning a server block, because those systems are configured to be more secure than usual. Then you can find more computers than the ping scans do. You're halfway there. TCP Scan, also known as TCP Connect Scan, is the default TCP scan type when SYN Scan is not an option. Well, when is the SYN Scan not an option? Do you remember the trip of data packet on a DNS query? In that lecture, I said that Layer 3 and Layer 4 packets are managed by the operating system of your device. That means user does not interfere with a TCP three-way handshake. The whole process is managed by the operating system itself. In a SYN Scan, we interrupt the three-way handshake and don't send a last ACK packet to complete the handshake. You have to be a privileged user to be able to interrupt the handshake. If you're not a privileged user, you cannot interrupt three-way handshake and cannot perform a SYN Scan as well. So instead of writing raw packets as most other scan types do, which needs admin privilege, Nmap asks the underlying operating system to establish a connection with a target machine and port by issuing the native connect system call. So you don't need to be a privileged user to perform TCP connect scans. When SYN Scan is available, it is usually a better choice. Nmap has less control over the high-level connect call than with raw packets, making it less efficient. The system call completes connections to open target ports rather than performing the half-open reset that SYN Scan does. Not only does this take longer and require more packets to obtain the same information, but target machines are more likely to log the connection, not too stealthy. The steps of TCP Connect Scan is exactly the same as TCP three-way handshake. You send a SYN packet to open a real connection and then wait for a response. A SYN ACK response indicates the port is listening or open, while a RIST reset is indicative of a non-listener. If no response is received after several retransmissions or an ICMP unreachable error is received, the port is marked as filtered. If you receive a SYN ACK from the target system, you send an ACK packet to complete the three-way handshake. Since we have nothing to say at the moment, we send RIST to end the conversation. Let's see what happens under the hood when we perform a TCP scan, and then compare the SYN scan with the TCP scan. Let's perform an Nmap TCP scan in our virtual network first. Go to Kali and open a terminal screen. I want to scan my Metasploitable system, so let's check if the host is up first. I know the IP address of my Metasploitable VM, so type ping 172.16.99.206 and hit enter. Okay, we received response packets. The system is up. Let's create the TCP scan command. Nmap is the command itself. S uppercase T is TCP scan. N is to avoid the DNS resolution. I'd like to see the IP addresses. Uppercase PN is to avoid the host discovery. I already know that the host is up, although you should make it a habit to use PN while you're scanning a single system. Now, we have the target IP address 172.16.99.206. And let's keep it fast. Scan for the top 10 ports only. I use top ports parameter for this purpose, and hit enter. Here are the states of the top 10 ports of Metasploitable. 7 ports are open and 3 ports are closed. Okay, let's open Wireshark and see what's happening when a TCP scan is performed. So you gotta run Wireshark first. Double-click ETH0 to start to listen to that interface. To skip the packets which we're not interested in, I add a filter. I only want to see the traffic for my destination computer, 172.16.99.206. And I want to see the TCP traffic only. Click the blue arrow next to the filter bar to activate the filter. To clear the packets we've already caught, I restart Wireshark packet capturing. Okay, now go to the terminal screen. I'd like to analyze the TCP scan packets for an open port first. I'm going to run the latest Nmap query again, but this time, I run the query for port 80 only. Hit enter and run the Nmap query. Yes, the port is open as I remember. It's good to know I'm not losing my memory. Go back to Wireshark. I want to stop Wireshark by clicking the red square at the upper left corner to avoid unwanted packets. Now here we have 3 packets. The first packet is a SYN packet to start the three-way handshake. It's from an arbitrary port of Kali to the 80th port of Metasploitable, the destination system. Second packet is a SYN ACK sent by the destination system. The third packet is an ACK sent by Kali to complete the TCP three-way handshake. And the fourth packet is a RIST sent by Kali again to end the conversation. This time, I want to scan a closed port, for example, port 81. Before running the query, I restart the Wireshark packet capturing to clean its screen by clicking the blue button in the upper left corner. In the terminal screen, I hit enter to run the query. As you see, port 81 is closed. Now let's look at the Wireshark interface to see what happened when we scan a closed port. The first packet is again a SYN packet to start the three-way handshake. The source system is Kali and the destination system is Metasploitable. The second packet is, for the scan, a RIST packet. Because port 81 is closed, the destination system sent us a RIST packet. So here we have a comparison between SYN scan packets and TCP scan packets for an open port. In SYN scan, Nmap has corrupted the three-way handshake by a RIST packet. In TCP scan, on the other hand, the three-way handshake is completed and the communication is established. So let's see the differences between the SYN scan and the TCP scan in a table that we've only really talked about up to now. Three-way handshake is not completed in SYN scan while it's completed in TCP scan. A RIST packet is sent when a SYN ACK is received in SYN scan, while an ACK packet is sent in TCP scan. Target machines are more likely to log the connection when the connection is established in TCP scan. No log for SYN scans because three-way handshake is not established. Because the native operating system call is interrupted, SYN scan has to be run by a privileged user. TCP scan uses a system call, so it does not need extra privileges. UDP scan is activated with the S_U option. UDP scan works by sending a UDP packet to every targeted port. For some common ports such as 53 and 161, a protocol-specific payload is sent to increase response rate. But for most ports, the packet is empty. Well, there are some options to force Nmap to send non-empty packets such as data parameter. Because UDP scanning is generally slower and more difficult than TCP, some security auditors ignore these ports. Now, I think this is a mistake, as exploitable UDP services are quite common, and attackers certainly don't ignore the whole protocol. So in general, destination systems do not respond when they receive a UDP packet. So Nmap doesn't recognize if the port is open or filtered when there is no response from the target system. In this case, the port is flagged as open or filtered. To force the systems to respond to our packet, you'd be better off using UDP scan with version detection option. You'll have much more accurate results. Let's perform an Nmap UDP scan in our virtual network. Go to Kali and open a terminal screen. I want to scan my Metasploitable system. Let's create the UDP scan command. Nmap is the command itself. N is to avoid the DNS resolution. I like to see the IP addresses. Uppercase PN is to avoid the host discovery. We've seen these before. S_U is to do the UDP scan. Now here's the target IP address 172.16.99.206. So let's keep it fast. Scan for the top 10 ports only. I use top ports parameter for this purpose. Now, as I said a minute ago, UDP scan should run with version detection. Use S_V parameter to use a version detection. I'd like to add one more parameter here, which is reason. Reason parameter is used to show the reason why the state of the port is set as open, closed, or filtered. Now hit enter. See what I mean? UDP is much slower than SYN scan or TCP scan because the destination system does not respond in most of the time, and Nmap has to wait more to decide the states. And moreover, we use version detection, which sends more packets to understand the service and the version. So this scan takes much longer than the SYN or TCP scan. One IP address and 10 ports scanned in about, 100 seconds. Wake up if you took a nap. Here are the states of the top 10 UDP ports of Metasploitable. Ports 53 and 137 are flagged as open because they returned UDP responses. And you see the version of the services listening to those ports. Port 138 is flagged as open filtered because there is no response. And the other ports are flagged as closed because they returned ICMP port unreachable errors. Let's see how Nmap interprets the results of a UDP scan. Occasionally, a service will respond with a UDP packet, proving that it is open. If an ICMP port unreachable error, type 3, code 3, is returned, the port is closed. Other ICMP unreachable errors, type 3, codes 0, 1, 2, 9, 10, or 13, mark the port as filtered. If no response is received after retransmissions, the port is classified as open or filtered. Now is the time to find out the services which are listening to those ports and the version of those services. In addition, let's detect the operating systems running on those systems. Suppose that you ran an Nmap query and it told you that ports 25 TCP, 80 TCP, and 53 UDP are open. Using its Nmap services database of about, 2,200 well-known services, Nmap would report that those ports probably correspond to a mail server, SMTP, web server, HTTP, and name server, DNS, respectively. This lookup is usually accurate. The vast majority of daemons listening on TCP port 25 are in fact mail servers. However, you should not bet your security on this. People can and do run services on strange ports. Even if Nmap is right, and the hypothetical server bub is running SMTP, HTTP, and DNS servers, that is not a lot of information. When doing vulnerability assessments, or even simple network inventories of your companies or clients, you really want to know which mail and DNS servers and versions are running. Having an accurate version number helps dramatically in determining which exploits a server is vulnerable to. And version detection helps you obtain this information. After TCP and/or UDP ports are discovered using one of the other scan methods, version detection interrogates those ports to determine more about what is actually running. The Nmap Service Probes database contains probes for querying various services and match expressions to recognize and parse responses. Nmap tries to determine the service protocol, for example, FTP, SSH, Telnet, HTTP. The application name could be ISC bind, Apache HTTPD, Solaris Telnet-D, the version number, host name, device type, something like a printer or a router, and the OS family, that is Windows, Linux, etc. So let's see how to use service and version detection in Nmap and why it's important. Okay, go to Kali and open a new terminal window. Let's create the Nmap scan command. Nmap is the command itself. N is to avoid the DNS resolution. Uppercase N is to avoid the host discovery. I'm using the SYN Scan this time. I write the destination IP, which is the IP address of my Metasploitable VM, and the destination ports, the top 10 ports. Let's run this command first to see the results of a command without version detection. Now, I open a new terminal window to create a new Nmap command. I prepared the command with the same configuration. SYN Scan, Metasploitable, and top 10 ports. I add S_V parameter for version detection and hit enter. As you see, the query takes longer this time. The SYN scan without the version detection took less than a second, and the SYN scan with version detection took about 12 seconds. In the first query, service names are estimated by Nmap according to the default services running on those ports. In the second query, on the other hand, Nmap probed the ports to determine more about what is actually running. Now, I want to show you the most important reason of using version detection in Nmap queries. In Kali, I'm going to run SSH on port 443 and then scan the port with Nmap. Let's perform the demo together. First, look at the listening services if SSH is running. Netstat, TNLP. SSH is running on port 22 at the moment. Type service SSH stop to stop SSH service and hit enter. Now, to change the port of SSH, we're going to change the configuration. Open the sshd_config file with a text editor to change it. I use Nano text editor for this purpose. Type nano/etc/ssh/sshd_config and hit enter. Find the port line, delete the sharp to make it a valid configuration line. The sharp was used to make it a comment line. Change the port number to 443. Control-X to exit Nano, Y to save changes, and hit enter to save over the existing file. Start SSH again, using the service SSH start command. Look at the listening ports to double-check netstat TNLP. SSH service is running on port 443 now. Let's scan port 443 of Kali with Nmap. Prepare the Nmap SYN Scan command. No version detection for this query. Nmap detects that the port is open. Look at the service. Nmap says the service is HTTPS. Using its Nmap Services database, Nmap reported that this port probably corresponds to a web server for HTTPS, and we know that's not true. So let's prepare the Nmap SYN Scan again, but this time use S_V parameter to run the version detection mechanism. Now, as you see, port 443 is running and the service is SSH, not HTTPS. Version detection interrogated the port to determine more about what is actually running. Nmap queried the port using the probes of the Nmap Service Probes database and matched expressions to recognize and parse responses. And the version of SSH is OpenSSH version 7.6p1. So, if you are not 100% sure about the type of the running service on a port, run version detection. Got it? Good. So one of the Nmap's best-known features is remote OS detection using TCP/IP stack fingerprinting. Nmap sends a series of TCP and UDP packets to the remote host and examines practically every bit of the responses. After performing dozens of tests, such as TCP/ISN sampling, TCP option support and ordering, IP/ID sampling, and the initial window size check, Nmap compares the results to its Nmap OS DB database of more than 2,600 known OS fingerprints and prints out the OS details if there's a match. Each fingerprint includes a free-form textual description of the OS and a classification which provides the vendor name, for example, SYN, underlying OS, that would be Solaris, OS generation, let's say 10, and device type, general purpose, router, switch, game console, whatever. OS detection is far more effective if at least one open and one closed TCP port are found. So let's see the OS detection in action. We have to use OS detection with one of the port detection techniques. So I use SYN Scan for this demo. The target system is Metasploitable. Let's choose top 100 ports to make the query faster, or just don't give any port. Let the Nmap scan top 1,000 ports. That won't take long. Put uppercase O for OS detection and hit enter. Here is the result of OS detection. It's a general-purpose device and running Linux with a version between 2.6.9 and 2.6.33. If you would like Nmap to be more aggressive to have a more accurate result, you can use OS scan guess parameter with OS detection parameter. Now, let's scan a Windows system and try to find out the version of EOS. So here I have a Windows 8 virtual machine. I want to learn its IP address first. Open a command prompt, type ifconfig, and hit enter. Now let's go to Kali and test if we can reach the Windows system. First, I'll ping the system. Now the system is not responding to the ping requests, or we cannot reach the system. So second, I perform an Nmap ping scan. We know how to do it, right? Type Nmap SYN 172.16.99.171 and hit enter. Yes, Nmap says the host is up. So we are able to reach the system. Now I want to scan the top 10 TCP ports of the system. I add the reason parameter to see the reasons of the results. All the ports we scanned are filtered because there are no responses from them. It's not good for us. So I add the OS detection to the latest Nmap query and rerun it. No, Nmap cannot find the OS details because it does not have a result set to probe or interrogate. I'd like to open a port on the Windows system and reply the Nmap scans. In Windows 8 VM, I run the IIS, Internet Information Services Manager, and start to host the default website of IIS. Open a web browser and try to reach the website typing the IP address of the system into the address bar. Okay, web service is up. Let's test if I can reach the website from Kali. I go to Kali, open a browser, enter the IP address of the Windows 8 VM, and hit enter. No, I cannot, and I think I know the reason. In Windows VM, let's look at the firewall, if HTTP traffic is allowed. So I open the firewall. At the upper left corner, I click Allow an app or feature through Windows Firewall link. Click Change Settings, which needs to have admin privileges. Go to the end of the list. As I thought, HTTP services are not allowed. Check it and click OK to apply the changes. Now in a command prompt to see port 80, I run netstat an command. When I come back to Kali, I see that the page is loaded in the browser. That means Kali can reach port 80 of my Windows 8 VM. Now in terminal screen, I want to run SYN Scan for the Windows system's top 10 ports. Here we have an open port now. So let's reply the scan with OS detection option. Now we have the OS detection result. First, Nmap warns us about the results. It says the results may be unreliable because it couldn't find a closed port to probe. But anyway, Nmap makes it best. And here, it says the operating system is one of them. Windows 2008, Windows 8.1, Windows 7, Windows Phone, or Windows Vista. Good job. So a few lectures ago, we saw how we identify which ports are scanned. Now in Input Management, we'll see how we identify which systems are scanned. Okay, go to Kali and open a terminal window. First, I'll prepare an Nmap query, and because I'll play with the destination IPs, it will be the last parameter of my query. Nmap is the command itself. N to close the name resolution, uppercase PN to close ping, S uppercase S for SYN Scan. Now to keep it simple, let's scan just the top 3 ports. Now is the time to identify the destination systems. Up to now, we learned to scan a single IP. And we learned how to scan an entire C block, .0 through 24. Okay, so what are the other ways of identifying target systems? You can select a range of any part of the IP address. In the slide, the 3rd and the 4th parts of the IP address is given as ranges. That means Nmap will scan IPs from 192.168.1.0 to 192.168.255.255. I'd like to keep the range small. I'll only define a range for the 4th part of the destination address from 100 to 150. There's only one machine between 172.16.99.100 and 172.16.99.150. You can scan more than one IP block in a single query. The example on the slide scans 2 ranges. The first range is between 192.168.1.0 and 192.168.1.255. And the second range is between 10.0.0.0 and 10.0.255.255. Since I don't have a second network on my Kali, I continue with the 3rd example. The 3rd example is a combination of defining a range and a single number. For example, you can scan the IPs between 100 and 140, IP 206, and the IPs between 220 and 230. So here are the results. Nmap found a machine from the range of 100 through 140, a machine with IP 206, and another machine from the range of 220 through 230. Another way to define the target systems is to give Nmap the IP addresses in a file. In a typical penetration test or ethical hacking, you'll scan the network a lot of times. First, you find the hosts. It doesn't make sense to scan the entire network again and again. You'll see huge networks, so if you scan the entire network each time, the pen test will take a lot longer than you think. Let's open a second terminal screen and find the hosts of our IP block using ping scan. As we learned before, now clarify the output to have only the IP addresses of live hosts. Grep command to get only the rows containing IP addresses. And cut command to get only the IP addresses from a row. Now we can redirect the output into a text file to reuse the list in following queries. But first, let me close the name resolution. Now, put a greater than character and give a file name to write the result, iplist.txt. We're not interested in the first two IP addresses. So let's edit the file and delete them. I use Nano text editor to edit the file. In Nano, use Ctrl-K to delete a line. Use Ctrl-X to exit Nano, press Y to save changes, and hit Enter to save on the same file. Type cat iplist.txt to look at the file again. Now we have 4 IP addresses in the file. Let's create a new Nmap query, and this time let's give the destination systems in a file, iplist.txt. And here are the results of the 4 systems which are listed in the iplist.txt file. So let's talk about the output management in Nmap now. Up to now, we've run a lot of Nmap queries and got the results on the terminal screen. This is the default output behavior called interactive output, and it is sent to standard output, std out. In a penetration test, we should save the results of the queries to be able to analyze them later on. Hopefully, Nmap has its own output management skills. So let's have a look. There are 3 major output saving formats in Nmap. Normal output, which is similar to interactive output. That's what you see on the screen up to now, except that it displays less runtime information in warning, since it is expected to be analyzed after the scan completes rather than interactively. Grepable output, which includes most information for a target host on a single line, so you can use it to collect the information you want using the excellent grep command. We've already seen a few examples of grep command in this course. XML output is one of the most important output types, as it can be converted to HTML easily parsed by programs such as Nmap graphical user interfaces or imported into databases. There's one more magic parameter, which is O_A to let you generate the outputs in all formats. Now let's see the Nmap output management in action. Go to Kali and open a terminal screen. Prepare an Nmap query. For this example, I want to prepare a SYN Scan. Now we're ready for output management options. First, I want to generate the XML output using O_X parameter. O_X parameter needs the output file name. You can give the file name with the full path. If you don't specify a path, just as in this example, the file is created in the current folder. Be careful. OX, OG, and ON parameters require the full file name. So if you want the file to have an extension such as .xml, you should specify it here. Hit Enter to run the command to see the generated file. Here it is. And use the less command to see the content of the file. So it's typical XML file with tags. Here's a host tag, starts and ends. All the results about a host is listed between the start tag and the end tag. IP address, scan ports, and of course, the scan results. Here is another host tag and the scan results of the second host as well. Press Q to quit, less command. Now let's call back our Nmap query with the up-down arrow keys of the keyboard. Now I want to generate all types of outputs. Type O_A and the base name of the files. Be careful, O_A parameter requires the base file name of the files, not the full names of the files, and it'll put the file extensions itself. Let's look at the content of .nmap file using the less Linux command. This is almost the same as you'll see on the screen. Now let's look at the grepable output. Here there are 2 lines for each host. One to show the status of the host, and another one to show the port scan results.